So y equals tangent x, if we don't have any other numbers, looks like this. Okay, because if you plug in tangent of 0, it should be 0. And then we should have vertical asymptotes at negative pi over 2 and pi over 2. And one reason you can rationalize that is tangent x is the same thing as sine of x over cosine of x. Because tangent x is just the opposite over the adjacent, right? So if you took the opposite over the hypotenuse and divide by the adjacent over the hypotenuse, you get opposite over adjacent. So every time you see tangent x, you could always rewrite it if you want as sine x over cosine x. And at x equals negative pi over 2, cosine of negative pi over 2 is 0. So that causes a divide by 0 problem. That's why we have vertical asymptotes here and here. That's when we don't mess with tangent. So look, tangent has a period of pi, right? If you multiply x by some number, then the period has been changed. So just like with sine and cosine, the period of tangent, instead of just using 2 pi, then we use pi over the absolute value of b, where b is that coefficient of x. So the period of this graph should be pi over 4. So when you sketch this graph, it should have the same basic shape, except it should repeat itself every pi over 4 units. That means instead of going from negative pi over 2 to pi over 2, going from negative pi over 8 to pi over 8. That way we have a full period of pi over 4 units. Pi over 8 plus another pi over 8, that makes 2 pi over 8. That would make pi over 4 units. So that's how you should drag the line. And if the blue dot or the red dot, whatever they're referencing here, let's see, drag either the red points and then a blue point for the correct coordinates. You just want to check certain values. So like tangent of 4x, I guess here, I think I got the Newton thing right here. That's Desmos. Let's see what they have for dots. Okay, so this is, I think this is a student's answer. Okay, so the blue dot that you would move is where it's going to equal 1. Looks like you can't move that. It has to be at 1. Definitely the red vertical lines, those are the vertical asymptotes I talked about. So that's why we have to move those to pi over 8 and negative pi over 8 and pi over 8, like I said. And then the blue dot, I'm not sure where you can move that. Maybe in Newton you can click and drag it up or drag it down, because I don't have the Newton test screen open for this. But what we can do is, if that blue dot is always where y equals 1, if you can't fluctuate that, then you're looking for where this whole function equals 1, like this. Okay, and then what you really want to know is, when does tangent equal 1? So what angle would you plug in to the tangent function to make it equal 1? And that would have to be, this tangent is sine over cosine, that would have to be the angle that makes sine and cosine be the exact same thing. Okay, so if you think about the known values we have, square root of 2 over 2 and square root of 2 over 2 are values that we often get, right? So whatever angle that would give you square root of 2 over 2 would get you a y value of 1. In other words, in the unit circle, the x coordinate is always cosine, and the y coordinate is sine. Okay, so that's why tangent of 0 degrees is going to be sine divided by cosine. So it's 0 divided by 1 here. Tangent of 0 is 0. We're looking for the values that would make tangent equal 1 on the y-axis, right? If we keep rotating, here's that perfectly break-even point where sine and cosine are the same. That's a 45-degree angle, okay? Because that makes, in the unit circle, it makes this side be square root of 2 over 2 and this side be square root of 2 over 2. So a 45-degree angle would make the x and the y coordinates the same. Sine divided by cosine would equal 1. So that's the angle. In other words, that's pi over 4 in radians. That's the angle that makes tangent equal 1. So we just need to figure out what x is, what the x coordinate is. So 4x needs to equal pi over 4. And to solve that equation, you would multiply 1/4 to both sides. So when x is pi over 16, you plug that in, you're going to get pi over 4, and tangent of pi over 4 equals 1. So we just did all the work in reverse to find out that when y equals 1, x-coordinate needs to be pi over 16, exactly halfway between the origin and that the right vertical asymptote. So that's where that blue dot is in their answer.